Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Well, welcome as we continue in our series of live broadcasts on for Reliable. Today we are going to touch upon this subject of combustible concealed space sprinklers. Initially, I was going to provide a background for you that included home for me is Southwest Florida, so that's where I'm broadcasting from today. So I was going to include a background that included palm trees and tiki huts, but given the recent spike in coronavirus, I thought that might not be safe. So we've decided to go in a different direction and just kind of give you my home office here. So again, today we're going to talk about combustible concealed spaces and more particularly combustible concealed space sprinklers. Now you'll hear them called a lot of different things by different manufacturers. Some people will call them interstitial space sprinklers. Other people will call them coin sprinklers. But for the sake of this presentation, we're going to call them combustible concealed space sprinklers or CCS type sprinklers. All right, so CCS sprinklers, they fall under the category of what we would call a special sprinkler. And special sprinklers are intended to protect either a specific hazard or a specific construction feature. So when you think about a specific hazard, think about a particular area like an attic sprinkler or a CCS sprinkler like we're going to talk about today. When you think about a construction feature, think about something like a window sprinkler, okay? So special sprinklers aren't just special because we call them that, but they're really special because we actually have to perform fire tests specifically related to that intended hazard. So most of you are familiar with UL 199, and UL 199 is a standard for most commercial sprinklers, okay? Now, CCS sprinklers also have to pass a lot of the tests required by the UL 199 standard. So when it comes to physical attributes of the sprinkler, structural elements of the sprinkler, corrosion resistance, endurance, impingement tests, or that type of thing, a CCS sprinkler is subject to the same criteria, okay? What makes a CCS sprinkler different is the fact that it also has to pass this specific criteria outlined in UL 199H, okay? So we have to actually take this sprinkler to a lab, we have to test it, and when we test it, we have to not only control the fire, but we also have two additional requirements. One is that sprinklers beyond those draft curtains that we've established in the test cannot operate. And the second is that we're going to provide some weight on those trusses, and we want to make sure that those loaded trusses don't collapse. So one of the reasons that we've chosen to revisit the CCS type sprinkler now is you can see where UL 199H was reissued in late 2018, and it was specifically reissued in 2018 because of a change in the way they looked at draft curtains. So in the initial standard, draft curtains were always limited to 1,000 square feet. In the revised standard, we're able to extend those draft curtains out to 2,000 square feet, or in some cases, not use draft curtains at all. Now, for some of you that have been in this business for a while, you're probably saying, well, you know, why don't we just use standard spray sprinklers in this application? Well, if you're talking about standard spray sprinklers, you're looking at a situation that looks kind of like this, right? This diagram has been in NFPA for as long as I can remember. I think if you're looking for it now, you would find it somewhere in the annex. But the key thing is, as you look at this diagram, what you're going to see is that you have a sprinkler at the top, and as the distribution pattern gets further and further away from that sprinkler, it also gets larger. So the distribution pattern at 18 inches is different from the distribution pattern at 4 feet, which is different from the distribution pattern when the water actually hits the ground, right? So why is that a problem? Well, let's take a couple Model G sprinklers and look at them side by side, right? We walked through this idea of special sprinklers, right? What they are. So we talked about this diagram that's been in NFPA forever, right? And the fact that it shows this distribution pattern of standard spray sprinklers. So here we have a scenario. Now we're looking at these two Model G sprinklers that are side by side. And as we look at these sprinklers, what we're going to see, and I'm going to try and use the laser pointer here, which I'm a little afraid to do, but hopefully it's going to work out okay, is that you're going to see that we have these umbrella patterns, but we do have this spot where those patterns start to overlap, right? The problem is that if we have a narrow space or a shallow space like a combustible concealed space, the place where these things actually begin to overlap is outside the space. So what happens is we end up with this scenario where we have these unprotected gaps within the space, right? So we not only have spaces at the bottom, but we also have spaces at the top. And since this entire space is a combustible space, that is concerning, right? Okay, so if we take this same situation and we look at it from a plan view perspective. So here you have a scenario where you have, different sprinkler distribution patterns in a plan view. And if we get a certain distance from that sprinkler, we may have distribution patterns that look like this. But if we look within the space itself, we may have distribution patterns that only look like this. And what that is going to create is this opportunity for horizontal fire travel. So both parallel and perpendicular to the truss space or the joist space, we have situations where the fire can travel within that space and the sprinkler is unable to fight that fire. So if horizontal fire travel is a problem and these gaps are a problem, then CCS sprinklers or combustible concealed space sprinklers are going to be the solution, okay? So if we take some CCS sprinklers and we put them next to our standard Model G sprinklers that we showed earlier, what you're going to see is a deflector that is obviously much flatter, right? And also slightly larger. So while the deflector on the Model G is designed to push that water into an umbrella pattern, with the CCS sprinkler, that flatter spray, it's actually going to discharge the water horizontally further. So it not only covers the space better, but it also allows you to locate those sprinklers farther apart. So in this case, we actually have an opportunity to space these sprinklers much, much further apart. So if we look at some actual pictures, here is a standard spray sprinkler and its distribution pattern. And you can see this incredible umbrella pattern that develops below that sprinkler. But if we look in the upper left-hand corner or the upper right-hand corner of that picture, what we're going to see is virtually no water distribution at all, right? But if we take a flat spray sprinkler, a CCS sprinkler, and we put it in that same application, you can see where we actually have some water discharge that is covering that space and discharging horizontally. So much, much better coverage for a flat spray sprinkler than a standard spray sprinkler in that environment. So what does the UL test criteria look like? Now, again, when Reliable completed this test, it was in a scenario where we were limited to a maximum 1,000 square foot test area. So actually this area is 40 by 24 according to the UL 199 document, so it's roughly 960 square feet. But there's a couple things to note. One is that you have these target sprinklers that lay outside of the draft curtain area, right? And then secondly, that we have this truss load that has to be located right in the middle of this space. Now that truss load is going to represent the maximum weight that you can put on the trusses that you've chosen for the test without collapsing those trusses. So they're literally going to stack weights in here to represent the maximum truss load for those particular trusses. And then, naturally, we're going to start the fire directly under that truss load because, you know, don't want to make it easy for us, right? So this is the actual video that reliable fire test for our KFR-CCS. It is not the best quality video that you're ever going to see, but I think it kind of gives you a pretty good indication of what this test looks like. Now, with all fire test videos, for the most part, we're going to start with our professional arsonist who starts our fire directly under our truss load, right? And what you're going to see is that this is about a 5.5 minute test. And we're going to fast forward a little bit through this test as we go, because it takes really a little bit of time for that fire to actually start to grow within that space. So another thing to keep in mind as we go through this test is if you want a CCS sprinkler that is approved for both wet and dry system applications, when it comes to dry system applications, what UL is going to do is, even after those sprinklers operate, they are going to hold back the water for an additional 60 seconds to mimic the delay that you would typically see in a dry system application. So the sprinklers in this situation are going to go off way before you actually see water discharge. And so what's probably happening if you're live on site there is you're going to see where this fire starts to grow pretty substantially. And I'm sure there comes a point in time where whoever is witnessing this test for reliable, whatever engineer is standing there, is starting to chew their fingers off because they're starting to get a little bit concerned about whether or not this sprinkler is going to do what it's supposed to. So you can see at this point, we are, you know, a little over 3 minutes in, 3.5 minutes in, and that fire is starting to spread out across the top of that deck. And at this point, we are at, let's say, the 3:45 mark. We are in a position now where realistically, those sprinklers have probably already operated, but the water is being held back by UL to mimic that delay associated with the dry system. And the engineers at Reliable are obviously starting to get incredibly nervous. You can see now where that fire starts to kind of just come under the draft curtain there. And right now you'll start to see where the water starts to discharge. Now, what I find pretty incredible is you don't really see the opportunity for water until about the 4:45 mark, but the test actually ends at the 5:27 mark. So in less than 45 seconds, those sprinklers are able to pretty substantially suppress this fire. So we ask ourselves those kind of questions all the time. Why don't we just use standard spray sprinklers in this type of environment? And the answer for that is that now we have technology where we've actually performed specific tests using that technology, and we know that that technology works. Why wouldn't we use what we should use, or what we know is going to be most effective in that environment? Okay, so the first reference, and I was surprised at this actually, and I actually had a bet with one of our other technical services managers, and the first reference that I saw for this was in 2007, which I insisted I was correct, but one of our other technical service managers insisted that it was 2002, and of course that was Brandon, and so naturally I owe him lunch. And so when we look at things like solid wood joists and open wood trusses, those are actually mentioned in the 2002 edition of NFPA 13, and the requirement for CCS sprinklers appears there. Now, on the left-hand side, you're going to see where we have some composite wood joists or engineered wood joists, and the reference for those actually does not happen until we get to the 2007 edition of the code. So, or let's call it the standard, because it is not a code, as Carrie reminds me all the time. Okay, so what happens when we have a space that's less than or equal to 12 inches? This is one of those things that was kind of left in the air with the original documentation. In 2010, this was addressed, where essentially NFPA came back and added this criteria that says if you have a space that's less than or equal to 12 inches, that space also can be protected using CCS type sprinklers. And then finally, there was this scenario where occasionally NFPA will recognize a flat ceiling as anything where we have a pitch that's 2 and 12 or less. Okay, so it's conceivably possible that we could have a scenario where the space is required to be sprinklered by CCS sprinklers when it's less than 36 inches. But what if we have a slope where that area actually increases to the point where it is now larger than 36 inches? What do we do with that? Well, that was addressed in NFPA 13 in the 2016 edition, where essentially it said that if we have a space where part of that space is less than 36 inches, and then it grows to beyond 36 inches, we can continue to use CCS sprinklers throughout that space, regardless of what this dimension becomes. Now, we may see some changes on what that looks like in the future, but at this point, based on current NFPA standards, whatever that space becomes, you can continue to use CCS sprinklers throughout that space. So, just to kind of summarize, where are CCS sprinklers required? Well, when we have a maximum slope that's 2 and 12, or when we have flat ceilings, if we have wood trusses, joists, or TJIs, where the deck-to-deck dimension is less than or equal to 36 inches, we're going to use CCS sprinklers. If we have a bar joist, but we also have a combustible deck, and that space is less than 36 inches, we are going to use CCS sprinklers. And if we have double wood joists, where the space between the top and bottom joist is 36 inches clear, we are also going to use CCS sprinklers. And again, keep in mind, we're talking about a sprinkler that has to be specifically listed for that space. All right, so let's do a couple definitions before we continue onward. When we talk about a joist, we are talking about the pictures that you see here on your screen. If you hear the word solid wood joist or conventional joist, okay, it is going to be like the picture you see on the left-hand side of your screen. If we talk about a TJI or a composite wood joist, it's going to look like this picture that you see on the right side of your screen, okay? What about trusses? Two scenarios we have when we talk about trusses. The truss on the left is what we would call a cord on face. So in this case, what you're going to see is that the top cord and the bottom cord are both flat against the upper deck and the lower ceiling, right? And when we talk about a cord on edge, we're talking about a truss like you see over here. And all we've really done is we've taken this 2x4 in this truss and we flipped it up on its edge. Thus the term cord on edge makes perfect sense, right? So as long as we see a cord on edge, that criteria is going to apply. Now keep in mind, there are two scenarios here. We have unobstructed construction, which applies anytime that top cord is less than or is less than 4 inches. But if we get to the point where that top cord grows to beyond 4 inches, so let's say instead of using a 2x4 on that truss, on the upper cord of the truss, we decided to use, let's say, a 2x6, then that becomes obstructed construction. And to a certain extent, the rules that apply to the installation of CCS sprinklers changes. So keep that in mind as we're going forward, okay? So what product does Reliable have that operates in this combustible concealed space arena? And the sprinkler that we have that works in that environment is our KFR-CCS. It is a 5.6 K-factor sprinkler, has a 1/2 inch NPT thread, okay? It is a 212-degree sprinkler, and as we saw in the test, you can use it in either wet or dry system applications. Now, it is a control mode density area sprinkler, which means when you look in the bulletin, you're not going to see what the flows and pressures are for that sprinkler. You're going to have to calculate them based on the spacing, okay? You can space it out to a maximum of 14 by 14. if you have a truss space that's less than 18 inches, or if you are using wood joist construction, you can space it all the way out to 256 square feet or 16 by 16 if we have a truss space that is greater than 18 inches deep. Now, also I noted there the minimum spacing is 6 feet. The only reason that's important is depending upon the manufacturer that you choose, that minimum spacing can change. I've seen 6 foot, 7 foot, 8 foot, depending upon the sprinkler that you choose. And also note, and I think it's important to note, that if Reliable is installing a sprinkler, for those of you that are familiar with our products, you know that if we are installing a sprinkler that we think is going to be difficult to access, we are going to install or manufacture that sprinkler using our quick response fusible link. We believe they are more durable and more robust than a bulb. And so if you're going to locate a sprinkler in a combustible concealed space or in an attic space that's going to be difficult to access, or most of our storage sprinklers, for example, where they're located at some pretty significant heights, our concern is those sprinklers are going to be difficult to access, and the quick response fusible link is going to be a benefit for you. One of the other advantages that you're going to find with the quick response fusible link is, since it is more durable, we do not have to ship it to you with a little orange clippy thing. And since we don't have to ship it to you with a little orange clippy thing, that means your fitters don't have to remember to take it off. All right, so there are a number, every manufacturer has some type of product where they play in this arena. Some have more than one. Okay, and you're going to see that as you look at these, you're going to see that they look pretty substantially different, with the exception that for the most part they utilize that flat deflector that we talked about. Okay, what's the same about them? Well, let's talk about what's the same about them. Is that for the most part, NFPA tells us that there are certain situations where we need to use sprinklers that are not ordinary temperature. And that is pointed out in the 2016 edition of the code in 8.3.2.5. Okay, and if you look under item 5 there, it lists about 10 situations where we have to use a sprinkler that is outside of an ordinary temperature. But when we look at number 5 there, it says sprinklers in an unventilated concealed space shall be of an intermediate temperature classification. And I think what's interesting about that is if you looked at the last picture, you notice there were some green bulbs, there were some yellow bulbs, there was there was a link sprinkler or two. The bottom line is, what's important to note is that all those sprinklers have to fall in this intermediate temperature range. So they all fall within that range of 175 to 225 degrees, okay? Required by the standard. All right, if you want to use CPVC in this particular application, regardless of the sprinkler that you choose, again, the rules are going to be pretty consistent. So if you have obstructed truss construction or you have wood joist construction without insulation, you cannot use CPVC. And that's going to be true for every manufacturer. The requirements of CPVC to be located a minimum of 18 inches from a heat source, that is also pretty consistent for any application where you're using CPVC. And CPVC manufacturers really want you to run piping towards the bottom of this space. So you're going to see here where your piping, if you're using CPVC, can be located a maximum of 6 inches above the top of the ceiling, or a third of the depth of the concealed space. So if your concealed space is less than 18 inches in height, you may have to actually be less than that 6-inch maximum. So keep that in mind. If you offset CPVC piping over the top of an obstruction, you are going to need to add a sprinkler over the top of that obstruction. Now, the good news is that, the bad news is that you have to add the sprinkler. The good news is that you do not have to calculate that sprinkler, and you do not have to make sure that it meets the minimum dimension from sprinklers around it, okay? And then finally, this idea of lateral bracing. If you are using 3/4 inch sprigs in your application and that sprig is over 12 inches high, you are going to have to find a way to laterally brace that sprig. Now, if you decide to use a sprig with 1-inch piping, you do not have to laterally brace the sprig, but you do have to provide a hanger at the truss that is closest to that sprinkler. So in this case, you would have to provide a hanger at this truss that's located right here. All right, another thing that I from everything I read, this seems to be pretty consistent from manufacturer to manufacturer too, and it's this idea of deflected distance, okay? And I think there's been a lot of confusion about this, so I think it's kind of important that we talk about this topic. When we talk about the location of the sprinkler, we're going to give you a dimension that tells you can be between 1.5 to 4 inches of the concealed space deck. Okay, so basically we give you a 2.5-inch window that you can install that sprinkler in when we are talking about unobstructed wood truss construction. Okay, now the important thing to note here, and something that we recently clarified in our bulletin, is the assumption here is that this deflector is going to be below the bottom of the top cord. So if you have a cord on truss, if you have a cord on edge that looks like this, or a cord on face that looks like this, and you locate this deflector 4 inches down from the ceiling, it's going to be a 1/2 inch below the top cord of the truss on the right, significantly below the cord on the left, and in either of those situations, we would be good to go, right? But let's say we add a sprinkler, like the one that I just added there on the left, right? So if we add this sprinkler, and now we locate this sprinkler so the deflector is only 1.5 inches down from the ceiling. It is, if we have a cord on face, in this case, because the cord on face would only be about 1.5 inches deep, the deflector and the bottom of the cord would be the same. So again, in that perspective, the deflector is at the same dimension as the bottom cord, or at the top of, bottom of the top cord, so we would be good to go. But what if we had a situation like this, where we actually have a deflector? It's within that 1.5 to 4 inch window that we talked about, but in this case, our deflector is actually located below the bottom of the top cord, okay? That would be no bueno, and that would be not acceptable as far as deflector distance goes. All right, what if we are looking at, instead of unobstructed wood trusses, what if we're looking at obstructed wood trusses, and we are looking at steel pipe because we're looking at obstructed wood trusses, right? Now we've got these trusses that are greater than 4 inch. And notice that in this case, our dimension that used to be measured from the concealed space deck above has now been shifted, and we are now measuring that deflector distance from the bottom of that top cord. And notice the window for installation of that sprinkler got way, way, way tighter. So what used to give us a 2.5 inch window in terms of where we can locate that sprinkler is now a 1/2 inch window, and it's got to be located from 1.5 inches to 2 inches below the bottom of the top cord. So some questions to ask yourself as you're trying to determine what sprinkler it is that you want to use within this space. And the first two are kind of combined or related, right? One is, what K factor do I want to use? But, that's going to depend probably on what your potential maximum spacing is. Another question that you want to ask yourself is, what is the maximum depth of the space? And then the final question is going to be, well, what do obstructions look like? Okay, so when you look at K factors of all those sprinklers that I showed you, CCS sprinklers are available pretty much throughout a range from 2.8, including 4.2 and 5.6 K sprinklers. The 2.8 K sprinkler that we're talking about here, there's really only one manufacturer that manufactures that sprinkler. It is a 2.8 K. You're limited to about 100 square foot spacing. So unless you're in a situation where you're really, really, really trying to limit flow, that is probably not going to be the sprinkler that you're going to choose. It is much more likely that you are going to be choosing between these two sprinklers, the 4.2K sprinkler and the 5.6K sprinkler. For the most part, 4.2K sprinklers are going to limit spacing to 144 square feet. 5.6K sprinklers are going to allow you to space those sprinklers in some situations all the way out to 256 square feet. So the sprinkler that you choose, again, is going to depend on what's important to you. Are you looking to limit flow, or gallons, or are you looking to maximize spacing? And if you're looking to maximize spacing, pretty much in most situations, the 5.6K sprinkler is going to be what works for you. Now, there is one scenario where you can use a 4.2K sprinkler that goes all the way out to 196 square feet. And again, no reason that you can't do that, but keep in mind, if that's what you choose to do, that at a 0.1 density, if we apply Q equals K times the square root of P, and we're using a 4.2K sprinkler, 196 square feet, we're going to require almost 22 PSI in head pressure. But if we use a 5.6K sprinkler in that exact same environment, we're only going to require 12.3 PSI in head pressure. So if you don't care about pressure and you have boatloads, you can probably use whichever one you want. If you're looking to limit end head pressure in this situation, the 5.6K sprinkler is probably going to work better for you. All right, height. Why does height matter? Well, in this case, let's look at it. We've got an open wood truss with a total depth of somewhere around 20 inches, right? So if you were to ask me the depth of that truss, I would tell you 20 inches. It's going to be the deck above to the ceiling below. But what happens if we put 3.5 inches of insulation within this space? Am I still measuring that truss to the bottom of the deck, or am I now measuring it to the bottom of the insulation? Well, NFPA tells us in the 2016 edition that we are going to measure that space to the bottom of the insulation. So we would take our 20 inches less our 3.5 inches for insulation, and the overall depth of that space would now become 16.5 inches. And again, the reason that that is important is you are going to have certain situations where your spacing is different depending upon the depth of that truss. As we talked about just briefly with the KFR-CCS, under 18 inches, the space with this type of construction, you're going to be limited to 196 square feet. And if you're greater than 18 inches within this space, you can space it all the way out to 256 square feet. So keep that in mind as we are going forward. All right. Let's talk a little bit about some of the obstruction rules. And what's really, I think, interesting about these sprinklers is every single bulletin from every single manufacturer, it shows the obstruction criteria differently. So if you go to our bulletin, we actually have 3 pictures that are going to show you obstruction criteria, okay? And I think this one that you're looking at here is a little bit deceiving, because it kind of looks like this is the top core of the truss and that this is the deflector relative to that truss. But we already know from the discussion we had earlier that the deflector on that sprinkler, if this is a truss, needs to be located below the bottom of the top cord. So in this case, when we're talking about this obstruction, we are talking about an obstruction that is other than the truss member. Okay. And I also want to point out this note, which was actually revised, I want to say Friday, maybe Monday, where we changed this criteria in the bulletin. Okay. And what it now says is that obviously the sprinkler deflector must be located at or below the bottom of the top cord. But if we have other web members, so if we have diagonal web members, or we have gussets, or if you want to call them truss plates, they are not considered obstructions as long as our minimum distance, our lateral distance from the member, from the truss member, is 4.5 inches or greater. Okay. We also have in our bulletin this idea of the 3 times rule. So if you have an obstruction to the side of that sprinkler, you're going to look at your obstruction and you're going to look at the width and the depth of the obstruction. And as long as your A dimension is 3 times the greater dimension, D or C, you are going to be good to go in that application as well. Okay. And then the last place where we talk about obstructions is when you have an obstruction below the sprinkler. Now, keep in mind, I think what's interesting to point out here is notice that this A dimension has now changed. Instead of you measuring that dimension to the front side of the obstruction, you're now measuring that dimension to the back side of the obstruction. And again, the reason for that is when you have an obstruction below the sprinkler, what you're trying to make sure is that you are going to have distribution of water over the top of the obstruction. So those are the three situations where we are going to outline for you what obstruction rules look like and what obstruction criteria looks like for a KFR-CCS sprinkler. But what if you find something that kind of falls outside that arena? Well, then these are the rules that are going to apply. And again, what's interesting, I think, is these rules differ from manufacturer. What we're going to tell you is if you've spaced that sprinkler at less than 225 square feet, then you're going to classify that sprinkler as a standard spray sprinkler, and you're going to use that standard spray criteria when we're talking about obstructions. But as soon as that sprinkler extends beyond 225 square feet, now it is an extended coverage sprinkler, and now you have to use more stringent criteria as far as obstruction rules go. So you would have to use obstruction rules associated with extended coverage sprinklers. Now keep in mind that, like I said, every manufacturer has different criteria here. One manufacturer actually has criteria where essentially they say if you're using their sprinkler, you are always classifying it as an extended coverage sprinkler, and as a result, you will always use extended coverage criteria to determine what the obstruction rules look like. All right, so let's play a little game. We'll call it, Is This Obstructed? You can see from the picture there that we have a sprinkler deflector that's located 3.5 inches from the ceiling. And we also have a sprinkler that's located about 10 inches from a truss plate, right? That truss plate, though, it's 8 inches deep and it's 12 inches wide. My goodness, isn't that sprinkler obstructed? Well, the answer there would be no, because if you remember, one of the obstruction rules that we talked about is if that sprinkler is 4.5 inches off the truss member, then truss plates and diagonal web members and bottom cords do not become obstructions. Okay, so in this case, that sprinkler would not be obstructed. How about a scenario like this? We've got obviously cords on face. We've got a sprinkler that's located again about 3.5 inches from the deck above. But notice on the back side, we have this additional support that runs along the back. It's a 2x6 or a 2x8, and that is actually the bottom of that obstruction is located below the deflector on the sprinkler. Would that sprinkler be obstructed? Well, the answer in that case would be yes, because in this case, this brace is not part of the truss. And so it is not, since it's not considered part of the truss, you have to consider it as an obstruction. All right, finally, let's discuss this idea of draft stops. So UL 199H gives us some specific criteria that we have to use when developing our test. And what it tells us is that the draft curtains that we use have to have a depth of 8 inches minimum or 1/3 the height of the truss. So if you have a truss that is, or truss space that is deeper than 24 inches, you are going to have a draft curtain depth that exceeds that 8-inch mark. Okay. Now, when we perform our test, UL also tells us what type of plywood is required to construct the draft curtain. And it's going to tell us that we have to use 1/4 inch thick plywood to construct the draft curtain. Now, what you're going to note in our bulletin, and I think everybody's bulletin from what I can remember, is that we are going to tell you when you ask us what to use as a draft curtain, we're going to tell you that the draft curtain may be constructed of 1/4 inch thick plywood, but we're not going to tell you that it has to be constructed of 1/4 inch thick plywood. So essentially, as long as you are using something that has a flame spread rating that is equal to 1/4 inch thick plywood, you are going to be good to go. Okay. One of the other things that it discusses in the draft stop section is this idea of draft curtains and what hydraulic calculations look like. So in our initial test, which was outlined in 5.1.3, we had draft curtains not exceeding 1,000 square feet. And so UL basically said that all of the sprinklers within those draft curtain areas are to be included in our hydraulic calculation and sprinkler system design. Okay. Now 5.1.4 is what applies when we have either no draft curtains or draft curtains that are greater than 1,000 square feet, and the criteria changes, a little bit. And essentially, what it says is that you have to calculate either no less than 6 sprinklers or not less than 1,000 square feet, whichever is greater. Okay, so let's look at a real-life application. This is a scenario where you're looking at an actual project that was designed by one of our tech services managers in a former life when he was designing for a sprinkler contractor. Okay, and what you're going to see is here we have a space that's about 24 feet by roughly 28 feet. Okay, we've got an outside wall, we've got a corridor wall, and then we've got these shear walls that go all the way up to the deck. Okay, in this scenario, you have a space that's 665 square feet. We've got 4 CCS sprinklers located within that space. In this case, there would be no reason to add extra draft stopping or additional draft curtains. We would simply calculate the 4 sprinklers within that space. And quite honestly, what we found is this is a scenario that exists quite frequently where draft stops are naturally located at less than 1,000 square feet. But there may be some possible situations where these new requirements at UL, or these new opportunities at UL, are going to allow you to provide draft stops at either over 1,000 square feet or provide no draft stops at all. And different manufacturers, there have been 2 manufacturers that have gone back to UL for testing under this scenario. Now, manufacturer 1 has essentially said, okay, we're going to build around these 2,000 square foot draft stop requirement. Everything that we do is going to be built around these 2,000 square foot draft stop requirements. And we're going to assume that for truss construction only. And we don't really care whether those trusses are on the edge or on the face. We're going to try and build around these 2,000 square foot draft stops. Now, if it's a wet system, it can be CPVC or steel. If it's a dry system, it's going to be steel pipe only. But essentially what they did is they took their spacing for 1,000 square foot draft stopping, left it exactly the way it was, and said, we're going to try and pass this test for 2,000 square foot draft stopping, and they were able to get that done. Okay, so then we have manufacturer 2. Okay, manufacturer 2 is essentially saying, hey, we're going to build this with no draft stops whatsoever. We're going to do trusses on face, wet or dry, right? We're going to do trusses on edge, wet only. So whether it's CPVC or steel, it's going to be a wet system. If it's a dry system, it's going to be steel pipe only. But what they said is, we're going to do something a little different. And we're going to say that in exchange for these no draft stop requirements, right, we may require some spacing concessions. So there may be some areas where you can go 16 by 16 if you're using draft stops at 1,000 square feet. But if you go no draft stops, you are going to go a maximum of 14 by 14. So this hydraulic design, now keep in mind, regardless of which of those that you choose, your hydraulic design is going to change. So hydraulic design is going to include either 6 sprinklers or 1,000 square feet, whichever is greater. Okay. Now there's also one other scenario where no draft stops are ever required, regardless of the manufacturer that you choose. And that's a scenario where you have steel pipe, okay? We have solid wood joists or composite wood joists. We have non-combustible insulation throughout that space, okay? And we have wire netting located at the bottom of that joist. Anytime you are using insulation within a combustible concealed space, UL is going to require that that insulation be held in place. And so that wire netting is going to be a requirement. But if you have this scenario, you can use any CCS sprinkler that you want, And essentially, all you have to do is calculate it based on the requirements of NFPA. So if NFPA said this is a light hazard application and you have to calculate 1,500 square feet, that's what you would have to do, and you wouldn't have to worry about draft curtains. If you could take the reduction and get that space down to 900 square feet, you could calculate that space based on 900 square feet as well. Okay, so a couple more slides, and then I'm going to bring this plane in for a landing here. I am always amazed at the creativity of sprinkler designers. And one of the questions that I want to ask you when it comes to draft curtains is there a way to use them to your advantage? So this is a scenario that actually played out once or twice that I'm aware of, okay? This is that same room that we showed before where we have draft curtains that are located around a 665 square foot space. But is there a way to use a draft stop to somehow work this to your advantage? Well, we've had scenarios where we've had contractors that have had difficulty calculating those sprinklers in that combustible blind space because of the additional elevation and the additional loss in pressure. They had very, very difficult time getting those sprinklers to operate. So what they actually did was they added in draft stops. And in this scenario, this is one of those scenarios where instead of calculating 4 sprinklers, they actually added in draft stops, so they only had to calculate 2 sprinklers within that space, and they were able to sell that to their AHJ. So again, just a thought, is there a way to use draft stops somehow to your advantage as you walk through these installations, okay? And then one other thing about the creativity of designers in our industry, right, is we have this note that essentially is going to tell you when you're offsetting CPVC piping over an obstruction that you have to add these additional sprinklers. But the truth is that in a lot of situations, I actually talked to one designer who told me they never, ever did that. That essentially anytime they had a scenario where they had to offset, instead of going over the top of it, they always went underneath it. And as a result of that, they were able to save their sprinkler that they would have had to install over the top of that obstruction. So that is really the extent of our presentation for today. I do want to leave you with ways to contact us should you need some additional tech support. Technical services, you can reach us by phone, 1-800-55-RASCO. You can reach us on the email line at techserve@reliablesprinkler.com. If you have any questions on this presentation and you want to talk to someone directly, actually the guy that helped me put it together, Mr. Scott Hansen, is on phones today. I'm sure he would love it if you called him to discuss this presentation. If you actually want to discuss the presentation tomorrow, I will be on phones tomorrow. So if you have a question specifically for me regarding this presentation, please do not hesitate to reach out to me directly. I would be very, very pleased to talk with you about what we're doing and where we see this going. And with that, I would be happy to take any questions that all y'all have.
Here is the first question that I'm seeing. Is the deflector distance from the bottom of the cord just discussed only applicable for steel pipe? Just curious, since that is what the slide said.
No, the deflector distance from the bottom of the from the bottom of the cord is going to apply whether or not you're using steel pipe or CPVC pipe. The challenge is going to be that if that cord is over 4 inches, it is going to be considered an obstructed construction, and you are not going to be able to use CPVC pipe in that application. So hopefully that makes sense.
Okay. And we have another question. Why is a dry system steel pipe only? Is it KFR-CCS listing? Because CPVC pipe is listed for dry systems.
But when it is listed for dry systems, it has to operate within a certain time frame, right? And so the issue with CCS sprinklers is we're delaying the operation for up to 60 seconds. So because of that 60-second delay, there's concerns about how that CPVC piping is going to perform in that environment. And so CPVC piping is not approved for CCS sprinkler systems, dry CCS sprinkler systems.
Well, those are the questions I see. It looks like we've had a good number answered in the chat. So I think that might be it for the questions.
Awesome. Well, again, I certainly appreciate you all taking the time to be with us today. It's kind of fun and challenging to try and join you this way. We certainly look forward to the day when we can do these kind of things in person again. But thanks again.